This is for section 2.6, number 21. In this problem, we know that there's a ladder here, and it is against the wall of this house, and this is the ground. So I label the sides using the following variables. Let's say the top of the ladder to the ground. Here, this is the distance is y. From the house to the bottom of the ladder, this distance is x. We do know that z is 25 feet. So here, this is what we know. Z is 25 feet. And we do know that the tip of the base of the ladder is pulled away at this rate, 2 feet per second. In other words, dx dt is 2 feet per second. We have to use positive 2 because this distance is getting larger and larger. So this is positive. Now what do we want? We want to find how fast is the top of the ladder moving down the wall when the base is 7 feet. For the other two, they're quite similar, okay? You just have to do something similar. So we're going to look at the 7 feet case. So in other words, I want to find how fast it is sliding down. That means dy dt, how fast this distance y is changing with respect to time. When x is 7, again, I'll just do the 7. I'll give you some hints on 7. You will do 15 and 24 in a very similar manner. So here's some hints. According to the Pythagorean theorem, x squared plus y squared is equal to z squared here. And z is a constant which doesn't change. So I'm going to just go ahead, plug in 25 for z, so 25 squared. That means x squared plus y squared is equal to 625. Now, think about we have to come up with the dy dt, right? So we have to differentiate this equation with respect to time t. X and y, they change depending on the time. So now we are going to differentiate it, okay? Differentiate it. And when we differentiate, think of x as a function of t. So you have to use chain rule. So it will be 2 times x times dx dt, right? Chain rule. 2 times x times dx dt plus the derivative of y squared is 2y times dy dt. Similarly, because y is a function of t, so use chain rule, 2y dy dt equals. And this is constant, so the derivative of 625 is going to be 0. Now, obviously, we can divide both sides by 2 to get rid of these 2. So that's why I crossed out the 2. And then this is the equation that we have. And we can use this equation, the new equation, to find dy dt. So here's what we know. When x is 7, therefore we are going to plug in 7 here, right? And then dx dt is known, which is given like 2 feet per second. So we do know that. Y we don't know yet, but we can find it. Dy dt is what we want to find when x is 7. So now how do we find y? Because x and y and z, they form a triangle. So therefore when x is equal to 7, using this Pythagorean theorem, so 7 squared plus y squared is 625, which means y squared is like 625 minus 49, which is 576. And then when you take the square roots of both sides, we ignore the negative value y because this y has to be positive. And y is going to be 24. So after we find the y, let's plug in all the values in this equation. X is 7, dx dt is 2, and y is 24, and dy dt is what we are trying to find. And then you can solve this equation quickly. And if I did not make any mistake, then it would be negative 7 over 12 feet per second. Now, how do you interpret this negative sign? That means this y, this value y, it is changing at the shrinking. The negative means shrinking. The distance of this y, the length of this y is getting smaller. It's shrinking at the rate of 7 over 12 feet per second. So this is the solution for the part A. Let's take a look at part B, okay? Part B. Consider the triangle formed by the side of the house, the ladder, and the ground, which is side of the house, the ground, and this ladder. I'm going to label this area as A. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall. This triangle is changing all the time when this ladder, the bottom of the ladder is pulled away from the wall. And we already know dx dt is 2 feet per second. And actually, in part A, right, we already know when x is 7, we just found the dy dt, which is this guy, which is negative 7 over 12 feet per second. And at that moment, the y is equal to 24 feet. We got all those information from part A. Now, we do need to find, what do we need to find? We need to find the rate at which the area is changing. So dA dt, that's what we are trying to find. dA dt when x is 7. So now we know the area formula for triangle is 1/2 times base times height. So therefore, I'm going to differentiate this with respect to time, both sides. So left side will be dA dt, 1/2 times. Well, we use product rule, right? So dx dt times y plus x times dy dt. So product rule. And then we know that dx dt is 2, y is 24, x is 7, dy dt is negative 7 over 12. So you just do the algebra, then that will be the answer. If this if this dA dt is positive, then area is increasing at that moment. If this area is negative, then the area is shrinking at this moment. I believe this area is actually positive. It's increasing at that moment. Okay. Now let's take a look at part C. Part C, find the rate at which the angle between the ladder and the wall. So here's the wall, right? And this is the ladder. So this is the angle we are talking about. So this angle is changing when the base of the ladder is, how fast this length, we want to find the rate at which the angle is changing when x is 7 feet from the wall. I actually can see that when you pull this ladder away, so I'm going to say suppose it's further away now, right? This angle is actually getting larger and larger. So eventually it will be, this tip will hit this wall, right? In theory, in reality, it may not be the case. So, here's what we want: d theta dt. Okay, how fast the angle is changing? Want d theta dt. So we from the part A, we already know when x is 7, y is 24, dx dt is 2, dy dt is negative 7 over 12. So we want d theta dt. So you need to come up with an equation that connect theta, connect x, y, or something. You have to come up with an equation. So in this case, I think of the tangent theta. Tangent theta is opposite over adjacent. So this tangent theta will be x over y. Okay, this is going to be a perfect relationship to use. I need to differentiate it, and I don't like to use quotient rule. Therefore, I multiply both sides by y. It becomes y times tangent theta equals x. Now I'm going to differentiate both sides with respect to t. So here the product rule says dy dt, right, times tangent theta plus function y times the derivative of this tangent theta. Again, theta varies. Theta is a function of t, so we have to use chain rule. So the derivative of outer function is secant theta squared times the derivative of theta, d theta dt, and the right-hand side will be dx dt. Now, we do know the dy dt, which is negative 7 over 12. Tangent theta. Now, let's talk about tangent theta. So, tangent theta is not known yet, right? We do know at that moment when x is 7, the y is 24. So, at that moment, tangent theta is opposite over adjacent, which is 7 over 24. So, therefore, I do know tangent theta. I can find it, which is 7 over 24. Okay, y is 24 and secant theta. Let's talk about secant theta. Secant theta is the reciprocal of cosine theta. And cosine is the adjacent over hypotenuse, right? So therefore, secant will be hypotenuse over adjacent, which is 25 over y, which is 25 over 24 because y is 24. So therefore, I have to plug in 25 over 24 in this secant theta. So 25 over 24 square. And this is d theta dt is what we are trying to find. Dx dt is 2. So now you get an equation and then you can solve for this equation for d theta dt. So that's the hint for number 21.